Here's the motor we took out. Note the wiring. A neutral lead, 5 line voltage speed taps, a ground wire, and a capacitor. Now the Azure motor wires exactly the way this motor wires. Neutral, line voltage speed taps, ground, but the Azure does not have a capacitor. That's the only difference. Okay, so the Azure motor is installed. Remember the wires on the PSC motor? Well, here they are. We have a white neutral, we have a green ground, and we've got 5 speed taps, just like the old PSC motor that we took out. We also have a programming cable, which I'll talk about in a second. And over here we have the jumpers. This is a voltage jumper, a rotation jumper, and then a mode of operation jumper. The Azure motor can replace either an X13 style constant torque ECM, or it can replace a PSC style induction motor. In this case, we're going to replace a PSC motor. Next, I'm going to auto-size this motor for this particular application. It's pretty simple. We'll connect up the ground lead. We'll connect up the neutral to the neutral on the board. We'll connect up the high speed tap to a L1 connection over here. Now in this case, I'm going to use a blower relay so that when I flip the switch on, the relay will send a plus 115 to the speed tap, causing the motor to run. We also have to connect up the programming harness. This is a 24 volt harness that goes from the motor up to any place you've got 24 volts on your board. I'm simply going to use the thermostat for my 24 volts. So when we power the system up, the motor will see a 115 volt signal, which makes it run. It also sees a 24 volt signal, which causes it to go into its programming mode, or its auto-sizing mode. It'll run for about 60 seconds and then stop. At that point, the speed taps will be programmed for this particular application. Now I'm going to go ahead and close up this blower housing and flip the switch on and let it do its thing. And the motor is starting. It's going to gradually speed up as it measures the RPMs and the torque necessary to move airflow. When it's all done, it will stop, and the torque will be assigned to each of the 5 speed taps. It's stopped. Now it's important not to remove power until the blower wheel stops completely. Then you need to remove the power. I'm watching it right now, and it's stopped. I'm going to flip the switch and kill the power. The motor is now programmed for this application. To complete this installation, I've removed the programming harness that was connected between the motor and the 24 volt signal on the board. We don't need this anymore. I'm going to leave the ground in place. I'm going to leave the neutral over here in place. And I've disconnected the red tap that we use to access an L1 signal for the auto-sizing. That leaves us with simply making the speed tap connections. And again, Azure connects up just where the old PSC motor connected. I've used medium-high for cool and medium-low for the high heat and low heat. The taps that are not used should be parked on your board if you've got a parking space. If not, wrap them in electrical tape so they don't come in contact with the ground on the cabinet. Lastly, you check airflow just to make sure everything is correct. If you need to make any adjustments, this is just like a PSC motor. You can change the orientation of the speed taps. That's about it. Azure is really unique in that it auto-sizes to each and every application, really optimizing the airflow for what you have to work with, because many times the ductwork is just not ideal.